And then the faceplate, sorry. So you can skip the faceplate part. Good morning and welcome to my home shop. My name's Jamie. Thanks for joining today. You know, we ask ourselves, at least I know I ask myself when project doesn't quite come out right, measurements aren't what I want them to be. Is it me or is it the machine? Do I need better tools? Because it couldn't be me, right? Well, more often than not, in my case, it's definitely me. Learning as I go here and getting a little bit better each time, but still have a long way to go. And maybe you've come across that same thing. Is it me or is it the machine? And that's the question that I'm hoping to answer today. And I'm fortunate enough to have this with me that came with my lathe. So I've got a Jet 1336 PVD lathe, and I'd like to understand what it's capable of, because if I'm asking it to do things that it's inherently not able to do, neither one of us wins in that case. But I have this inspection record that came with the lathe. This is dated September 1987. And what's really cool about this is it has all of the measurements that were taken for the lathe as it came off the assembly line, starting with bed levelness, so transverse direction as an example. So going across the ways, here's an image of what the precision level would be looking like and where it'd be placed. Here's the tolerance, and here's the actual result. So I have that for essentially every measurement on the lathe, including run out of the nose. And my plan today is to go through. I'm going to keep track of what the current stats are, and we'll take a look to see how well this lathe has stood the test of time since 1987. And, you know, I'll be using a lot of different measuring tools and techniques to kind of follow along with this, and let's see how this lathe shakes out. Let's get to it. All right, taking a quick look at the calibration of our machinist level. So I found the plane on this surface plate where I have the bubble level. And the test here is rotate that 180 degrees. Put it back in the same position. I'm using this square here and the 1, 2, 3 blocks as a guide. So I make sure that it's back in the same spot. And we are level. So I've adjusted the height on this, gone back and forth a whole bunch of times to make sure that this is perfectly calibrated. So with that, we can use this confidently over at the lathe. All right, I just tossed a couple of pieces of flat stock underneath the back, about 1/8 of an inch thick, to at least see if I can get the bubble within the range. And perfect, we are within range of measurements before the bubble was fully on one side. So if we just take a look, you can see we now have something that we can read. 2 bars out, which means, yep, so I'm tilting this way. So the back's a little bit higher. 2 bars there. This is twisted. Yep, so that's what this is telling me, is that we are twisted quite a bit, actually. Because this is now reading 2.5 this way. So this needs to come up This back corner needs to come up, so that's counterclockwise. So before I fine tune the twist that I have in the bed, I generally have it level, again within the markers on the level. But then I'm also low on the headstock end from a level perspective. So I'm going to cut a couple of pieces of sheet metal here to kind of jack up the entire back end and see how close I can get it with some of these larger movements. And then I'll work with the bolts that are holding the lathe to the table in order to tweak and fine-tune the measurements. So we'll cut up a couple of pieces of these the sheet metal and use this as shim stock. All right, so hopefully you can see this. I need to bring the headstock up. So I've got these couple of shim pieces that I'm going to pop underneath. Let me know how that looks, and when it gets to about 1 bar on each side, just shout so I stop, and that'll help me so that I know that it's in the right spot. All right, how's that look? Holy smokes. That's pretty good. Man, look at that. Within half a bubble with sheet metal guesses on thickness, I'll take it. All right, let's take a quick look here how we're doing crosswise. Give you another look at that. Yeah, so we're 2 bars that way. Let's head down here. And now we're 2 bars this way. Okay. And let's try 5/1000ths of an inch. 5/1000ths. Looks like it's just not quite enough. Let me try, go back to 6. All right, looks like 6/1000ths would be just what I need. So there's 2 bolts that mount the tailstock down at this end. I'm going to loosen them up. I'm going to put a 6/1000ths shim underneath that bolt. See how it goes. So with the lathe basically roughed in the best that I can, a little bit more than roughed in I should say, because I have taken some time to put some shim stock down at the end to take the twist out of the ways. I've got it about as good as I think I can get it. And what is that? And how much is it on or off level? So starting here at the headstock, I am looking at about 1 marking off. Let me show you what that looks like. Snag a picture of it. So if I look straight down on it, the bubble is just about on that second line. And I come down here to the tailstock. Give that a moment to settle down. And I've got about the same reading, which is at that second line. So although the ways aren't perfectly level transversely, from front to back, they're almost identical. About 20 inches over. from this side of the ways. I just want to get a sense for what the middle of the machine looks like. And I'm right at 2, second hash mark again. So that looks good. Another thing that I can do is I can test, because I'm riding currently on the peak. So the ways have the peak and they have the flat. And both the carriage and the tailstock ride on those. Alternatively, the tailstock rides on this peak and on this flat, and the carriage rides on this peak and on this flat. So another thing I can do is take these 1, 2, 3 blocks to test the flats to see just how flat they are, or just how level things are here, measuring off of the flat parts. I've already tested these 1, 2, 3 blocks for accuracy on the surface plate, and they are indeed accurate. So I can put this up here, and I can be shocked live on the video to see that those are way off. Let me give you a look at what that looks like. It's not even reading right now. So something is just not right here. Or I'm just thinking of this wrong for it to be this far off. So let me check here in the middle. Same reading, it's bottoming out. Let me go down here to the end. Same thing, bottoming out. That is very peculiar. Not sure why I'd have such a variation between the top of the peaks and the top of the flats. So let's measure exactly how much that is. So in order to get this level off of the flat part of the ways, from this edge of the 1, 2, 3 block to the leading edge, which is where the indicator, the feeler gauge would be hitting, I am at just about 5 1/4 inches. So across that span, in order for me to get back at the second line, which is consistent where I was on the top of the crowns, I've got all of these spaces here. So I'm looking at 35 and a half, 36, 37, 38. Let me measure these up. So I'm looking at adding in here. That is 62 thousandths of an inch. 61 thousandths of an inch of spacing to get that leveled out. Let's bring that down to the tailstock and take another look here. Do the same setup. So the 1, 2, 3 blocks. Get the off the bubble indicator. Let's take the same 61 thousandths. And I'm very close to that 2 mark. So whatever it is from this side to this side is consistent. I need to learn a little bit more about whether or not these have some sort of an intentional difference in height. All right, moving on to the longitudinal measurement. What we're looking at here is measuring along on, it looks to be both the, well, it's really kind of hard to tell on this diagram, but on the flat part of the ways, and we'll also check on top of the crown. So measuring here on the back flat. We are just about where we want to be, level-wise. Show you what that looks like. Let's check the crown. I'm holding that because it's just kind of balancing there. Show you that image. That also looks to be level, and when I'm saying this, I'm within a quarter of a bubble, or a quarter of a distance in between the markers. This one looks to be out about 1 mark. And the front measurement looks to be about a quarter, maybe a quarter of a mark. All right, checking here down on the back. That looks spot on. Check on the first crown. That looks pretty good. It's about a quarter, perhaps. Check the second flat. That looks to be in good shape. And we'll check the front crown. And that, again, about a quarter of a mark. So longitudinally, it seems to be in pretty good condition. And let's move on to the next measurement. All right, the next measurement I'm going to do is we're going to ride the carriage. I have a tense indicator here on the ways, and we're just going to run it down more just over halfway and see what kind of results we get. So let me bring this carriage over to about here. All right, so we're at about 0. Let me just, yep. All right, so we're about 0 here. And so as we run it down, plus or minus 2 or 3 tenths. All right, and then we got a big jump right here. Let's see if that's repeats. And it does. So we're at +1 right here. And all the way down through that area. and then it drops right off. So from right here it pops up to 1, 1.5. So we'll call that 1.5. Yeah, it goes very sharply up to 1.5 to about, so we'll call that whole thing 1.5. Keep going. Drops down a little bit, and now there's some rough. I can see there's some rough there. Let's run it back through there again. So right about that 1.5. Drops down to about 1 right here. It's a quick 0. That could be surface finish. And we're back to 0. Yep. Now I'm in and around that 0 marker. Fairly consistently. And that's plenty far enough there. So that's 0 to there. So we've got a bump up from here to here of about 1.5 thousandths. Let's just double check it by rolling it back. I'm at 0. Yep, it goes up to 1, 1.5. And now it should kind of drop right off. It drops right off quickly right there, and we're back to 0. So what this is telling me, where we're seeing the indicator rise, means that the location where the indicator is mounted, which I'm circling here, is lowering. So the ways are worn in this area, and it's causing a positive reading on the dial test indicator. Okay, so we're at 0 right here. Point 0.5. Holding at 0.5, back to 0. Slightly under 0, but about 2/10. Now I'm at negative 0.5. So I've got a negative 5 right there. Coming back up towards 0. And we are back at 0. So we come up 5 10,000ths. We go down a little bit, about half a thousand. So to hit on this point again, it's at these two locations on the ways where I'm seeing the indicator rise. On the flat way, I got 1.5 thousandths of a rise, and on the V way here on the front, only about 0.5 thousandths of a rise. But what that means is as the indicator is rising, that's because the bed that the indicator is traveling on is lowering. So these circled areas indicate the areas of the ways that I'm seeing that wear. All right, another test we can do to check out the wear on the ways is to use the tailstock ways as a benchmark. These ways, especially in this area, you're not sliding the tailstock back and forth. So what I have is mounted to the carriage. I have the indicator on the flat way for the tailstock. let's dial that in. We'll zero that out. And then let's move down and see what sort of difference we get measuring here. And that, might tell me if relative to these unworn areas, just how much the carriage is moving. So I'm getting about 0.5 thousandths plus or minus. So it's actually about 2.5 thousandths, sorry, 2.5 tenths plus or minus the 0. So I'm really not getting much difference in relation to this flat way. But I'm going to bring it closer. I'm going to flip it around to the other side so that I can bring the carriage closer to the headstock, which is where most of the wear would be. All right, so we're zeroed out here. All right, and then we move to about 5 tenths, back to 0. So I'm at about 2 tenths, 5 tenths, 7 tenths, and then back to about 0, about 2 tenths. All right, so let's write some of these down here. So we're getting some activity. And this is in relation to, let's see, so we're really measuring, so we're at 0. All right, so we're at 0 up to here. And then we go to 5. So holding at 5. And we get to about 0 here. And then we drop off. So in this area, we're at 0. And then relative to the ways here, which is going up, which means the carriage must be going down. And then we come back to 0, or about 2 tenths. Let's see if we get a similar reading on the V-way of the tailstock. We're at 0, we're at a minus 5, oh now we're at plus 5, plus 9, and now we're at minus 9. All right, so let's zero out here. So from 0 here, now we're at 1.2. That's 1 2 tenths. That's 1.5. That's 1.7. It starts to drop. And right here we're at 0.5. 1.2. 1.5. And we're at about 1. So I have the most increase across a broader area here, 1.2, 0.5, 1.3, 1.7. So I'm interpreting all of this to mean that the flat way on the back that the carriage rides on is more worn than the V-way in the front. All right, next is the spindle center runout. And for that, we're going to set up the indicator right here. So, looks really good. I'm getting about 1 or 2 tenths. That looks good. Next is the spindle nose. So we'll bring this up to the outside diameter. All right, I'm at about 2 tenths right there. And we're getting maybe 2 tenths, 3 tenths. So that looks pretty good. The tolerance there is 4 tenths, so we look like we're right where we need to be in that regard. The next is what they call in the inspection record is the spindle cam. Measuring that, I'm calling that end play. That's what I would call that based on the image that they're showing. So we're going to 0 that. And then going to just rock this back and forth. And I'm not getting really any. Make sure that so I'm at 0 here. Maybe a tenth. Yep, not really getting anything more than a tenth. And at the factory, that was measured as 4 tenths. So it says total indicator reading with indicator on rear side of test plate. I'm not sure. I don't have a test plate, but I am, again, not getting much more than a tenth on this movement in and out this way. Just following up on that last test. Let's just, with the indicator here, let's see what we get, if we get any run out this way. This could be, I'm getting plus or minus 3, maybe 4 tenths. So there's a few measurements here that require the use of a test bar that's mounted into the spindle head directly without a chuck. I don't have that set up, so I'm going to skip those. We'll come back to using a test bar in a moment. Next, we're going to go to some of the tailstock spindle alignment tests. So we've got the tailstock. We're going to do a couple of tailstock tests next. And what we're going to check here, tailstock spindle alignment horizontal. So forward at end of spindle when fully extended. All right, so let's extend this out. Okay, so I'm at 0 right here. And as I roll this out, I'm at +5, 0, -5, -1 when it starts getting into this. Looks like it actually tapers off. That's -2 thousandths right here. All right, so we'll call that 0. Keep hitting the numbers that are here on the side, and it's changing up my answer. But we're at 0, now we're up to 0.5, 0.5 to 0.9 to 1/1000th of an inch, 1.5 to 2 thousandths. So this tells me that the spindle horizontally is rolling towards the back. So I'm starting here at 2 thousandths of an inch this way, and the more I come down here, back down closer to 0. All right, let's check the vertical and see what we find on the vertical side. Okay, so we're at about 3. Ignoring the bumps, you can see we're generally progressing up. I don't know, maybe, is this thing tapered? I wouldn't think so. Looking back at the video now, I can see what's happening is the ways are worn out. And so as the carriage moves through that portion of the ways, it's dropping down and giving this positive reading on the indicator. So I want to do a quick check on this quill here on the tailstock. So I've got a measurement here at the back of 259, and I've got a measurement here in the front of 259. So this is not tapered. So to get those readings that I was seeing, I was getting variation this way as well as elevation. It could be because of the ways and the way the carriage is moving along the ways is causing that to read differently. So since we know that that is not tapered, let's check to see the alignment by, instead of moving the carriage, let's move the quill and see how the gauge responds. All right, we'll zero that out. And you can see that, okay? So we're at 0. Moving that through. So no change there. So as expected, that seems pretty good. And then the other thing we could do is move the tailstock. So as we move the tailstock, I get less than 1/1000th of difference. So that seems pretty good. The next few tests are on the chuck. And so what we're looking for here is run out of no more than 3/1000 really across the whole chuck. So 3/1000 on the face. Whoop, I just bonked it. So we look good right there. That's looking, oh, I hit it again. Let's lock the carriage so that I don't induce any more error. Okay, so we're at 0. Basically 0. So the face run out here looks really good. Okay, then to check the jaws. So the jaws here, I'm at 11. 11. 11. And 11. So that looks good. Now let's check the side. And again, we're looking for 3/1000. Zero that out. And what do we got? So we're up to 5, down to 0, to 5, down to 0. So we've got 5/1000 of run out across the perimeter. So I know it's one thing to be level, and level is sometimes used as a proxy to make sure that your ways aren't twisted. But as everybody always says, these things were mounted on ships that sailed the ocean. Clearly level is not important as much as it is being flat. So what I'm going to do now is I'm going to come back to my test bar. So what I have here is a test bar I had made earlier that has a center hole on each end, and these sections here are exactly the same diameter. And so I'm going to bring this up in between centers and mount it, and then I'm going to measure the distance on this end to see if my tailstock is lined up. And then that'll also give me a sense for how the ways are looking from a measurement standpoint. So the first thing I'm going to do is I'm just going to true up this dead center. So I have my lathe mounted here at 30 degrees, which will make a 60-degree cut. And let's go ahead and do that right now. Okay, so with that, now I know I have a perfectly concentric point on this end. I'm going to go ahead and mount this up. We've got the test bar set up, and what we're going to do here is zero this out, So I've got good concentricity, very little movement of the needle. I bring it all the way here to the outer piece. Again, pretty good concentricity there, and I'm measuring at about 3.5. So I need to go that way so that I can balance out the two differences here. So on this tailstock, there are adjustment screws on either side that move the tailstock kind of left and right. And on the back end is the locking screw. And one of my viewers gave me the advice that said, look, you're tightening the adjustment screws too tight. You know, just go ahead and make those snug, but you don't need to crank down on them so much. So let me take that advice and see if I can tune this in a little bit better. So there's the back adjustment. I'm just going to snug up the front one. And now I'm going to tighten the back. Hopefully we don't move a lot. All right, so that looks pretty good. Didn't move too much there. So we'll roll this back here to the front. And let me re-zero. Okay, that looks pretty good. Bring this out. Check the tailstock end. And I am at 2, so I need to split that difference again. Do this one more time. See if we can get that 1/1000th out of there. There's my 0. And actually, I probably went a little bit too far because I'm now at -1 here. Although that's very close. All right, that's very close. Within 1/2 thou. I'm going to tighten this down and call that good. All right, so I've got 0 here on the tailstock end. And I've got 0 here at the headstock. Okay, so that's great. That tells me that my tailstock is now dialed in as nice and true and square as this could be. Great. So with the tailstock lined up, let's do a few different test measurements. First thing we're going to do is drill a center in here, and then I'll do some shorter measurements, and then ultimately we'll get it set up on the tailstock. So that's making some weird noises. Spindle fluid looks good, but I'm going to put some more in the back one. Let's see. Looking at these sights, looks like the back spindle could use some more oil. All right. Let's see, is there anything else under here causing a fuss? Everything looks good. It's just the belt squealing a little bit. this is a really tight, short measurement, but let's just start here. Let's see how it looks. So on the outside of this, I am at 77.15, and how many tenths? 715.4. So 715.4, if I bring it back closer, yeah, I'm getting just about the same measurement. Okay, so that's good. Let's pull it out a little further. Unsupported. We're not taking a deep cut. That's a pretty good stick out though, isn't it? Let's just test it. All right, let's see. All right, so if I just double check this measurement one more time, now that I have my glasses on, we're at 705. And then off the vernier, it looks like 705.6. And then we go here to this end. And we're at 705.7. Great, so we're only 1/10 off. That's really good. Let's check the middle. $705.6. Maybe 7. It's very close. 705.7. Okay, so we're within a tenth. That's pretty good. I like that. All right, now let's go way out. We'll give this some tail support. Let's see what we have here. Okay, so I'm at 6, 75, 85, probably 86. It's really 85. 685.9. All right. Let me write that down. 685.9. Way out there on the end. Let's jump right here to the headstock. And we have quite a difference here now. This is at 6, so it's 75, 80. So that's 682. Really at 682. Really 682.1. 682.1. Oh boy, so I'm off basically 4 thousandths. So isn't that interesting? We have something happening right here. Yep, we're at 686. That's 686. And then it starts to fall off, getting smaller. Right around here. So from here to here. So in that area, so from here to here, I've got an idea. All right, let's check here. All right, so we're at 0. Still holding near 0. And then there it goes. Wow, look at that. So it's dropped off now 3. That's about 4 right there. 3, 4. And then anywhere here it should be coming back up to 0. And it's getting closer. There it is there, now it's 0. So isn't that interesting? It's diving in this last little bit. All right, so that tells me that, you know, within this space here, within the first few inches, I have fairly accurate 1 or 2 thousandths of an inch. But then, you know, across the length of it, you know, not as accurate. What do you guys think? Normal? Not normal? What am I missing? I appreciate any feedback. So knowing this, let's check one more thing. So we'll take the tailstock out of the way. And again, we're going to use the tailstock ways as a guide. And what I want to just measure here is the carriage pitching. The carriage should be pitching towards the work as we get closer in. And I just want to see if there's another way of confirming that. So let's run it back here. So I'm at 0. As we hit that area, yep, it starts to drive in. That's exactly what's happening, is the carriage is falling in as we get closer to the chuck. Let's see if I can show you that here with my phone. Okay, let's see. Well, let's ride the carriage in. All right. All right, well, here I am at the end of a few days worth of work, spread over probably a couple of weeks of pulling this video together. We do have a new puppy in the house. That's kind of changed my shop time a little bit. The holidays as well has taken this video a little bit longer to come together, but it's been good because I've been able to sleep on some of the findings that I've had. And as I went through the process, I thought it would be pretty cut and dry to come running through this inspection record and just replicate the testing and, you know, be able to check the measurements. And as with a lot of projects in the shop, things just don't always work out the way that you expect them to. So having the time each night to think it through and come up with different ideas was really helpful. You know, one thing that I keep coming back to is the one of the tests here around with the collet chuck test, which 1 inch from the collet chuck, it's expecting 1/1000th of an inch of tolerance here, you know, if this was a collet chuck setup. And to me, that just seemed, you know, I was kind of worrying about being off 1 or 2 thousandths. And this machine, you know, from the factory was, you know, quote unquote accurate to 1/1000th of an inch. So maybe I'm doing okay from a measurement standpoint. So that was one indicator, but it took me kind of going through this whole process to kind of realize the tolerance that they had put here. The other one was around the chuck run out. So the chuck run out at 3 thousandths, you know, was within tolerance. This video spent a lot of time on trying to figure out why the diameter of these cuts was changing so much, you know, in and around this kind of 3-inch marker. And, you know, and that difference is anywhere from, you know, 2 to 4 thousandths, depending on how well I measure, which that does seem like a lot, right? I don't know if there's compounding errors happening here, but with all the different tests that we did, I know that I have wear on the ways that's causing the carriage to pitch inward as we get closer to the chuck. So, I mean, I've come at it now from 5 different directions and they're all pointing to the same result. So it is what it is where I'm gonna kind of leave this project. You know, I know that within a few inches of the chuck, I've got pretty good accuracy. Anything outside of that, I'm gonna need to be more careful. But it's been, as promised, a really good brain exercise to go through. I've got measuring tools all over the place. I've got the whiteboard filled up with all sorts of measurements and calculations. So it's been a fun project. I'm a little bit glad that it's over. It's taken a long time to pull this one together. The editing took a long time on this one because I was trying to make something that, you know, was a bit dry and at least make it entertaining. So I hope you've enjoyed it. If you did, consider, you know, give me a thumbs up would be great. Consider subscribing if you haven't already. I would appreciate that. And as I hinted at the beginning of this, the whole reason for doing this video was because I'm going to be making a project which I had intended on it being some relatively tight tolerances. But now I understand, you know, anything within 1 to 2 thousandths, I should be in pretty good shape. So that's coming up. But again, thank you very much for watching. I do appreciate it. And as always, good luck in your home projects. And until next time, we'll see you.